Good afternoon, everybody. Welcome to Bring the Power of AI to your Amazon Connect Contact Center. My name is Mark Rutkowski. I'm a principal consultant for the Amazon Connect specialty practice.
I'm Laura McFarland. I'm a technologist at Liberty Mutual. I'm going to be walking through the architecture, design, and testing of our virtual agent.
Hi, my name is Dan Perry. I'm a senior product owner on the emerging technology team at Liberty Mutual, really responsible for self-service.
Great. So in terms of the agenda today, we're going to walk you through how Liberty Mutual delivered an automated self-service contact center experience using Amazon Connect and AI services such as Lex and Polly. Dan will walk us through the business case and through their production voice bot application. Laura, as she just mentioned, will walk through the architecture in detail, and I'll close out with some quick best practices. You already know who I am. So when it comes to improving your contact experience, we have a set of AWS services that really allow developers to get up quickly, start quickly, and really not get into the weeds of developing their contact center experience. And with that, we have Amazon Connect, which is your contact center as a service, right, which can be provisioned in minutes. We have Polly, which is essentially a text-to-speech service, which we use to generate the voice of Alexa. Transcribe, which actually does it the other way from Polly, right, and it takes the speech and turns it into text. Translate, which takes text from one language and translates obviously to another. Comprehend looks inside a document for all this text and the context and allows you to gain insights such as sentiment analysis. And then Lex, which is our NLU, or natural language understanding and speech recognition capability that a lot of customers are using to build chatbots and, as you'll see today, IVR systems. Lex is the same system that we use to power Alexa today. So as an example, when a call is handled by an agent, those calls are recorded into the contact center, and businesses are able to take the transcription from those conversations, and they want to gain insights in terms of what's happening when the agent and the customer are having those conversations. And by using services such as Comprehend, you can look into those and automatically gain insights based on sentiment analysis for that, and then feed that into your systems, such as a CRM system, right, to gain those insights. And what we're seeing with AI is it plays a key role in terms of improving your customer experience and efficiency in the contact centers. For example, customers can use Amazon Connect with Lex and all of its speech and NLU capabilities to basically leverage the interaction that they're having with your customer service experience, and then leverage those to then handle approximately up to 40% of those calls, and really take that load off the agents, allow the agents to focus really on higher value activities, as well as have the ability to reduce the queue contention that you may see with agents. And as you'll see today, you'll see some of that as Laura and Dan walk through that. So let's dive into how Liberty Mutual implemented this with their use case. Dan?
Thank you. All right, so we're going to start with a quick demo, so brace your ears while we adjust for the sound.
Ah, crap. I got into an accident. Appears to be a minor fender bender. Thankfully, everyone is okay. Well, I suppose I should call Liberty Mutual to report a claim. Thank God for insurance. It looks like my car is going to be in the shop for a few days. Do I even have rental car coverage? Guess I should give Liberty Mutual a call.
Dun, dun, dun. All right, so we had a bit of fun teeing this up, but if you allow me to keep you in suspense for a few minutes, we'll circle back to finish up the call demo. So what you just heard is fairly representative of a typical P&C inquiry. Insurance can be fairly esoteric to those that don't work in the industry, and more so it's a product that ideally you never need to use. But at the end of the day, we sell customers on a promise. And when they need to reach out to us, they expect that time of day doesn't matter. They should be able to connect with us 24 hours a day, 7 days a week. They also expect not to be put on hold. If they are put on hold, certainly for not a prolonged period of time. And moreover, just expect their question to be answered as quickly as possible. And who doesn't, right? It really makes sense. And you can start to sum up a lot of these external customer needs and realize that it presents an internal opportunity for us as well. Annually, we receive tens of millions of calls across our claims and service call centers within the US. And many of these calls are repetitive and direct, and thus offer up the chance for automation. And so taking a step back, you can look at these internal and external customer needs and realize there's a pretty big opportunity in front of us. Then along comes what I like to consider this big bang of the voice revolution that we're currently experiencing, really colliding with the evolution that we're seeing in chatbots. And it's resulting in this massive shift toward voice-driven functionality. And when you stop and think about it, it really makes sense for a variety of reasons. Firstly, talking is faster. The average person types at 50 words per minute and texts at 40 words per minute, whereas the average person speaks at 165 words per minute. And so talking is 3 times faster than texting and 4 times faster than typing. Backwards. 3 times faster than typing and 4 times faster than texting. It's also really convenient. From a self-service perspective, it requires 0 clicks. It's something we're accustomed to doing. And it allows us to multitask. Good examples are the aspiring chef who is asking for the next ingredient in the recipe, or a carpenter asking for the square root of, say, 187 inches. And there's also, voice agents become increasingly accessible. So whether or not it's the smart speaker in your house, and now potentially your car, the phone in your pocket, your laptop, your tablet, your Xbox, or some other device. And really, this is all fueled by the cheaper and cheaper costs for natural language processing and cloud computing. And so you can take this voice revolution that we're a part of and start to assimilate it with the evolution we're seeing in chatbots, where chatbots are becoming smarter and smarter, able to provide and process an increasing number of data points across an increasing number of platforms. And you realize that voice-driven conversational chatbots really offer up a solution to the opportunity we have in front of us. And so knowing there's an opportunity, at least on the surface, we started to think through various frameworks to help us assess the practicality of implementing a chatbot as a solution. Of course, we don't want to just chase shiny new technology if the runway for its applicability to our business is fairly short-lived. And so one of the frameworks we thought through was a simple scatter plot showing frequency versus conversational complexity. Frequency here is the measure of the recurrence of a question over a period of time. For those that may be less familiar with some chatbot terminology, here each question is more or less synonymous with an intent. And of course, there are many ways to ask the same question. We refer to those as utterances. And thus you have this many-to-one mapping of utterances to an intent, which is more or less a question. So again, here frequency is a measure of the recurrence of an intent over a period of time. Conversational complexity, as the name would suggest, is really a measure of how straightforward or complex an intent can be. By way of example, do I have rental car coverage? That's pretty straightforward. Do I have the appropriate insurance for my family? That's a bit more nuanced. And so naturally, there's this sweet spot as you embark on your chatbot journey where you're really going after those intents that are highly frequent and straightforward. And so this scatter plot is, of course, illustrative, but really, for us to populate this, we pulled from a wide breadth of resources, including call transcriptions. So we had thousands of calls transcribed across our claims and service call centers. We analyzed those calls to put together a first pass at populating this scatter plot. We also have actively listened to calls between our claimants and our policyholders and our call center representatives. Many of us had never sold insurance, serviced a policy, or handled a claim. And so for us, this was great insight, not only into the customer experience, but the various modalities used to fulfill various intents. We also pulled telephony data. So going back to conversational complexity, you could envision something like average handle time or the propensity for an intent to be woven together with other intents as a proxy for conversational complexity. We also sat down with the folks that are actually taking these calls to really validate if our data-driven approach mirrored what they were seeing on the phones. And then really as a secondary measure of validation, we looked at back-end system transaction data. So what were the actions taken by the call center representative, and did they align with our expectations based on our categorization of the intent or intents of that call? Ultimately, what this means is that we we cataloged and categorized all of these resources into this giant corpus of utterances, intents, various fulfillment services, heuristics such as master intent, sub-intent, and a whole host of other business metrics, and we branded it as a meta library. And really, call it what you will, it was our approach to using data to not only assess the opportunity in front of us, but build a framework for execution. And so knowing there was a clear road ahead, we embarked on designing an MVP, really with the goal of hitting upon 3 key items. Firstly, we wanted to build an MVP that would actually interact with our customers, so something that would live in a production environment. Secondly, we wanted to build a chatbot that could answer a subset of claims rental-related questions. Going back to that scatter plot, this was a good opportunity because it was straightforward and frequent enough to allow us to get our feet wet, but allow us the opportunity for future enhancements and scalability. And then lastly, we wanted to build a chatbot that really touched upon all the KPIs we would need to assess broader scalability and really validate some of our assumptions. And you can really categorize those KPIs into 3 core dimensions, starting with business viability, which more or less is a measure of whether or not this particular endeavor is economically sound. So some example KPIs that would fall into this dimension include things like infrastructure and maintenance cost, average handle time changes, call volume changes between the current telephony environment and this new environment, speed to market, how quickly can we roll out a subject matter expert chatbot, cost per call, and a host of other metrics that we really boil down into a financial model to forecast ROI. Again, going back to that scatter plot framework, you could envision a z-axis, or the size of each intent dot or data point, as really representative of the ROI of an intent or a group of intents. The second dimension is customer desirability. So we could build a really awesome chatbot, but at the end of the day, is it something that our customers will engage with? And can it embody our company and our customer-centric values? Some example KPIs in this dimension include things such as utterance recognition, so the many ways a diverse group of people can ask the same question. Repeat requests, how often does the chatbot need to ask the caller to repeat themselves? A more straightforward measure of CX, which for us was a survey given on the heels of their interaction with the chatbot. And the last dimension is technical feasibility. And I won't spend a ton of time here, as Laura will really go through the nuts and bolts of the design and infrastructure of our chatbot. But some example metrics here include things such as ability to integrate with our current systems, the intent development process. Is it GUI? Is it code? Do you need a special skill set? How quickly can you build and train one of these bots? Of course, things like contractual terms. And then I'd say a modifier of sorts for enterprise direction. So this is a quickly evolving space, and we want to leverage a product that is investing in innovation so that we can adopt the latest and greatest and don't become laggards. So with that said, hopefully you have a sense of why we embarked on this particular endeavor. We'll circle back now to round out the demo, and then I'll hand it over to Laura.
Our records indicate you have an existing rental car reservation with Enterprise. Would you like to hear the details?
Yes, please.
According to your claim file, your rental reservation with Enterprise is scheduled to begin on November 28, 2018, and approved through December 3, 2018. You can pick up your rental at 4517 West Flamingo Road, Las Vegas, Nevada. The daily approved amount for your rental car is up to $30 per day. What other questions do you have today?
Are tolls and gas included with that?
Your rental coverage covers the actual cost of renting the car up to the daily policy amount. Any additional deposits, cost of gas or tolls would be your expense. What other questions do you have today?
What about mileage? Is there any mileage restrictions?
We have contracted with Enterprise to provide you unlimited mileage. If you have chosen a different rental company, you will need to ask them their policy on mileage. What else can I help you with today?
What is the contact info for the rental company again?
Enterprise is located at 4517 West Flamingo Road, Las Vegas, Nevada. You can reach them by calling 702-365-6662. Would you like me to connect you with your local Enterprise?
No.
What else can I help you with today?
I think I'm all set.
Okay, great. Based on your experience today, how likely are you to recommend Liberty Mutual to a friend or colleague on a scale of 0 to 10, 10 being extremely likely?
So that was Lex, left Lex, the whole stage there. So I'm going to talk through what's the architecture, what design did we put behind the call. So we're using Amazon Connect to get our calls directed from our call center software into Connect, and then Connect orchestrates everything, pushes it through to our Lex bots. Under the hood, we're using DynamoDB and AWS Lambdas. So this was, to say the least, a whole new world for most of the team on the project. We're a bunch of web app Java developers. We're used to our GUIs. We know what a style sheet is, home screen, all great. Throw that out the window. We're in this world of the VUI. So this is voice user interface. All absolutely, completely brand new to everybody on the team. So we had to, you don't style it, you choose a persona, so that's how you want it to sound. This was a little bit easier for us. We just wanted to be a professional call center persona. Made sense. You do an introductory sentence, just like when you call a normal call center, you still have to give this kind of introductory sentence. But like even this was tough, because do you start with hello? Do you go hi? You don't want to be overly friendly. We wanted it to be a call center person. Hello was just a little bit too static, so we went with hi, but that was maybe a day's work. We only allow Lex to misunderstand twice. It can be very frustrating if Lex will, and you can program different ways to say it at random. Can you repeat that again, please? I didn't quite get that. It becomes really frustrating if somebody's on the phone. Maybe the accent couldn't be understood. So that's it, twice. Lex is out, 2 strikes, not 3, she's out. And then we take it back to the call center. So we just want the customer experience to be positive. They've got through pretty quickly into Connect and Lex. There's no time waiting there, but if Lex doesn't understand it, we're out. For even your script flows, you need to be able to handle things like it's natural language processing. So people say, can you repeat that? If you don't program for it, Lex will just say, can you repeat that? And kind of into an infinite loop there. So this is the kind of things you have to listen out for and to define. So text-to-speech, TTS, again, this is our new world. We're used to all of this now. We have a new markup language, which is speech synthesis. So this is where, with Lex, with just regular text, it will pause if you do a full stop, a comma, whatever. It takes nearly a natural breath, which is what you want it to sound like. But you can change it with SSML to change things up. So things like you can add in an extra pause. And even with that recording, when Lex was giving out the address, Lex says numbers really fast. So you can actually just SSML it and just get it to slow down. And it still sounds really natural. It's not like a real slowdown. There's the whisper one. You can play around with this in Poly. Completely freaky. You don't want to put that into your call center to whisper to your people. So, and again, with these scripts, it was all new to us. So we actually got everything reviewed with a UX, user experience psychologist, and they gave us really great feedback. They also held experience testing sessions. Does this sound right? Have we got it correct? So, and we did that quite early on in the project. Again, we were all learning a lot, so it was great to get this feedback really early on. Scripts and flows. Again, this is like our requirements, how on earth do you define them? So it really is just, it's flow diagrams and it's got decisions and everything like that. And we defined it in Lucid Chart. It's a great way of being able to share across information just online with our friends and colleagues in AWS. And we're from a Belfast office. We're working with folks in different parts of America. So it's a great tool just to share everything. So you don't find a UX psychologist around every corner. This is where we had great partnership with our AWS. And we used them in consultancy roles. So we had our UX psychologist, but we also had Mark, our resident Amazon Connect. Can code, but we used them as consultancy, and we had Lex experts online as well. The reason why we didn't want them to become coders in the project is that we wanted to learn from the ground up. We didn't want to be given code and not really understand everything. So we coded it, used the guys in reviewing capacity, consultancy, and their feedback was fantastic. And again, it just kept us, it was a really fast turnaround time, just keeping that MVP online. So learning and evolving the architecture. So obviously we played around with Lex in the AWS console. It's a different experience from coding, but it's a great way to learn, all the intents, all the slots, just how you drive Lex. Pretty quick, maybe within a couple of weeks, we had full understanding of how to hook in Lambdas, how to get Amazon Connect to transfer calls over to Lex. And Connect also hooks into Lambdas in the control flow. So it was this all new, all super fast speed, but really pleased that we could see this emerging serverless architecture kicking off. And if somebody had told me I'd be writing a serverless project, I'm like, wow, brilliant. I embraced it. A few top tips here, some kind of best practices. This is a little patronizing. Read the API. If you don't read the API, you will not understand the limits that AWS sets on all of your components. So Connect has a maximum number of concurrent calls. Lex, well, obviously you can only have so many concurrent Lexes running. Your things like that, if you don't understand those default limits, you won't fail, but what will happen is you kick into the throttling of all the AWS offerings, and then you're non-performant. You're basically putting people into a queue, effectively. So you don't want to do that. The default limits can get changed, but it's your understanding of your project, of your use case, where you want to sit that at. And like obviously we were quite a small project starting up, learning from it. We're going bigger and bigger, taking more calls every day, and you've got to expand. And it's the perfect way to do it. It's pretty quick to change them. Get out of the console early. I said we'd learned Connect and Lex, just using the console, just learning how to drive it. But I wouldn't say it's the easy part, but learning CloudFormation templates to get your Lambdas pushed up into AWS is really not, for a Java developer, it's not that easy. So it's just getting used to that way of coding. You've got many languages that you can choose from to define your Lambdas. C#, Python, Java, Go, Node.js. I think Node.js seems to be where everybody tries to go to, pretty much because a lot of the examples are in Node.js, so that's your good starter for 10, and then everybody kind of, you add on to that. And we were a polyglot team at one stage. We had Java, Node.js, Python, tinkering with Go. But that's choice, that's great. Nobody says just do it this way. Java wasn't the hottest in Lambdas. You got to spin up your JVM. And then you have a keep warm, you're pinging it. You've now got an anti-pattern. So Java, not so good. Got to define your reporting, alerting, testing, defining your CI/CD pipeline. If you don't do that early on, you're going to struggle to, get your fast turnaround time, get your fast feedback on your tests and everything. Got to react to AWS, chucking out those changes every day. It's great that they do, obviously do that, but you got to keep up to date with them, and that link there is where everything gets pushed out. I haven't looked at it in the last couple of days. I'm sure it's pretty big with the reInvent being on at the minute. So a couple of examples that we went into production in February this year, and immediately put out was encryption at rest. We didn't have encryption at rest, which is why we had one of our Java Lambdas, because then we had encryption library within it. So we were glad to jump dump that Java Lambda, because then just put on encryption at rest. Just a tick box, brilliant. Get rid of a big heavyweight Lambda. Point in time recovery. I'm sure there's new stuff. Not sure what's coming out this week. I'm going to that tomorrow for more in Dynamo. So the evolving architecture is how we started. This is where we started from, and this is where we evolved to for our MVP. It's a really solid architectural pattern that we have seen other companies kind of, Mark, you've been working with other companies, you're seeing this kind of pattern being repeated. It's great. So sharing our pattern. So I'm just going to walk through the call flow, the data flow, and just why we put this architectural pieces together. So we've just got a call coming in to a call center. Somebody's calling about a claim. The call center software is going to gather up information about that caller. So there's still no person interaction here. For our MVP, then we have rules that will define should that caller get sent through to Amazon Connect. So the rules are up in our call center software. It pushes the call into Connect, and at the same time, it's pushing data into AWS. And the only way you can do that is via Amazon API Gateway and into our DynamoDB table. And it's quite lightweight data, but it means we've got information, that high-level information about the caller. So everything in Connect is sequential through flows, control flows. So Connect has received the call. The next thing that we want to do is from Connect's Lambda, go and get that initial data. So you can't push that data into Connect. There is no payload with Connect. All you're getting is the caller's telephone number. That then is our ID that we can go in. That's our unique ID for that caller. We can go and get the information out of our DynamoDB table. So what our Lambda is doing there then, it's just creating an event that's going to get pushed onto an SNS. So it's just simple messaging, pushing the event onto a queue, and then down below it, you can see there's a number of other Lambdas there. So this is like a publishing, subscribing model. The Lambdas will react to that event coming in. So it's just a really simple new call event with caller ID and everything. So that, by pushing it onto the topic, onto your messaging queue, you're now asynchronous. Because if I have to, so the phone call has been shipped over to Connect, but this is all lightning fast, not as long as it's taken me to speak. But putting that event onto the queue is absolute microseconds. What Connect is then doing, it's falling into its next flow to do that introductory sentence. But I have no data elsewhere in AWS except that initial data from the call center. So what's the Lambdas down at the bottom? Their job is to go and get the data out of our other Liberty Mutual systems. They're not in AWS. We need to get that data into AWS. So what we're doing there is we're front-loading all of the data. The reason for that being that, okay, I've still just done my introductory sentence to the caller. I'm now going to be shipping information over to Lex. Lex needs to respond with data to the caller. And I don't want to have wait time going and getting the data real time. I want to have it all loaded up first in AWS right beside where Lex is. So I'm making that super fast. If we didn't have that there, your timing to get the data is just too long. So again, this is why this is a really good pattern that's established here. So introductory sentence done. Connect has that limited amount of initial data to know what Lex bot to ship over to, because Connect cannot listen to what the person is intending to say. So it's over to Lex to then listen to the person. So they're going to, our MVP was just for car rental information, so this is now what Lex is listening out for. what information do you want about the car rental. So Lex then still hasn't got the data, but it's doing the listening out. Goes and gets the appropriate piece of data. It's now got intelligence to talk to the caller. So once the intent is fulfilled, and you heard in the demo, we don't just do one intent, goodbye. We're always asking, what else can we help you with today? And you can do that as many times as you want until the person says, no, I'm done. So then once it's done, it gets shipped back over to Amazon Connect. Connect is the orchestrator of the call. Where should it go to next? And you can define, and we have defined in Connect, that if they want, you heard the address and telephone number of the enterprise. If somebody says, do you want put through to enterprise? If they say yes, you ship it back to Connect with the telephone number, and then Connect will dial out to enterprise. So again, it's the full orchestration of the call in and out. And it will also orchestrate to the next Lex if that's what we've defined. And again, that's what you heard on the call. Once they didn't want put through to the car rental, we then went to what is our feedback bot. How would you rate us out of 10? So just a little bit under the hood, just to the intent. So that it drops into the intent. Lex recognizes it. We've got the intelligence from our data that they've already got car rental. Do you want to hear about it? Yes, I do. And then again, it's this kind of like static text that we'll have once we know what way the person's taking the call. We're not forcing them down a certain way. We still want the natural language. It's the caller that directs the conversation. Then always our follow-up prompts. So I say we've got 2 bots in our MVP. We've got a lot more now in different areas of claims insurance queries. But our rental bot has got 23 intents, which is a lot. And again, from the early part of this project, I think I struggled to even understand how to define 2. And the fact that we grew it to 23 successfully is quite mind-blowing. But it's all the different areas of car rental questions. So you can see in the middle, we've defined base intents. So we're proper Java developers. We know how to do OO, and this is what we're doing. We only write the code once. So this is where we've got 3 intents. So you've got a closure, a repeat, and a speak to. And we refer to these as non-intents. This is not what we'd programmed the rental bot to do, but this is us listening out for the natural language. So the closure is somebody saying, thanks, bye. It's those kind of no more questions, thank you, I'm done. The repeat, like I said, if the caller says, can you give me that number again? We literally just, that's what you have to listen out for. Otherwise you get into that infinite loop. Can you repeat? And then the last one, the speak to. If the caller doesn't want to speak to Lex, we are not forcing them to stay in the Lex bot call. If I want to speak to a real person, I don't want to speak to a bot. If you don't program for that, it's a horrible user experience. So again, we listen out for that. If that gets into that intent, we take them out to the call center. And then just the feedback bot. So it only has one intent. It's just asking that question, can you rate us out of 10? So we learned on our journey to our MVP a great best practice of how to define your sample utterances, and that's by using slots. So our system is not gathering slot information, because all we want is intents to be fallen into. We don't ask them lots of questions, like what's your policy number? We don't gather that information because we've got it. We know what their telephone number is. We know all that information. So just with our MVP, no slots gathered, except in the feedback bot. It does listen to, give me your score out of 10. So with each of our utterances, you can see that this is a full intent. I think there's about 12 sample utterances there, but we use our slots as enums, synonyms. What that saves us doing is the permutation combination. If you didn't use that, I don't know how many there'd be. I'm gonna guess 60, 70. That gets hard to test. That gets difficult to keep track of. It's just very difficult. So this best practice is the way to go. So how do we test it? Testing was absolutely key to the success of our project. I showed you we've got 24 intents with I don't know how many sample utterances. You cannot test all of those. You don't know if you have defined them correctly. So you have to you have to have automatic testing. So this is our test, and again, I think it is a really good practice. So with Lex, you've got a runtime API. So your Lex is up and running. You can run it in our dev environment, is where we run our tests. But it's just a URL out to, you're sending information to Lex, and you can send just text to it. We talked at one stage, should we do voice tests? And then we realized, no, you're just testing voice to text. We don't own that. There's no point in testing it with voice. You just test it with text, because that's all Lex is responding to. So just an example of, it's just a post out to your bot that's running. Part of the content in the request is the utterance text. What you get back in the response is the intent name that it fell into. So this is how we build up our tests. We know what the text is. We assert on what intent it should fall into, and it should only ever fall into one intent. So we just have arrays of actual tests. You can see that some very obvious ones that you would maybe have come up as your own test data, but we were lucky enough, I shouldn't say lucky, it was just fact, that all of our test data came from our call center transcripts. So these are all real questions that have occurred over the last few months on people asking agents information about is their rental authorized. But if you look at the last one, there's no way we would come up with that as test data. You guys haven't approved the rental yet. That's not a question, that's a statement. But this is the kind of thing that happens, and this is what we need our Lex intents to recognize. So say it's all automated, CI/CD pipeline. Each time somebody's gonna put code in, we'll run just the normal, sensible way of coding. You've got your Sonar lint check style, so we've got clean code from the get-go. Once it's all kicked in, Bamboo job will kick off all those tests, and then we pull the results into Allure. And that's a fairly straightforward way of people running automated tests. It's nothing really new for Connect and Lex. So we have over 3,000 example tests just for our car rental. So the guys on Amazon, they recommended that we should have a 75% pass rate of the intents falling into the text falling into the correct intent. Our first run was really bad. This is 36% pass. That's way too many failures. We are not going to production. And you can see that this was us first running it on the 13th of February. We were needing to get into production at the end of February. This is head and hands moment going, crap, we're not going to make it. But great set of developers, and we've just gamified testing. 36%, no way, we're going to fix this, we're going to make it better. So every time, new high score, still not good enough, game over, try again. And we had one of our developers, I think it was about a week before going into production, you could see he was posting into Slack, I'm at 60%. An hour later, I'm at 70%. And it just kept on going. So So how do you fix it? How do you get your results to be better? You obviously look at your failures. What intent didn't fall into the one that you'd expected it to fall into? You maybe have to tweak your sample utterances. You maybe have to take some away. If you have your intents falling into the wrong ones, it's called, referred to as intent bleeding. It's gone the wrong way, but you don't really know why. So the whole idea is that you just keep on slightly tweaking things and only ever one intent at a time. If you change 2 or 3 intents, you actually don't know what you fixed, and you may have made it worse in one of them, and you don't know. So only ever one at a time. So it's rerun, test, repeat until success. So just these are real examples. You can see before our refinements, and this is why we failed. As programmers, this is how we think people will say things. We're not mind readers, we're just programmers. So you can see that each time we have put rental in front of authorized, and again, this is using our enums for the slot gathering. So what we hadn't done, you can see in green in the second set after refinement, we hadn't put authorized in front of rental, and a few other ones there that we hadn't, just authorized needed to be in. So it's things like that. Without the test data, this is why we fail, but you just don't know that. So it was absolutely invaluable. 26th of February, yes. February's a short month. We got to 91%, and that was absolutely amazing. It's like, say, Amazon guys had said 75%, no chance, we're going high. So how do our callers interact with Lex? It is predominantly short intents. People mostly know they're talking to a bot, and it's nearly like a demand rental setup, but it's how people do it. A few you will get fully fledged sentences, but not as often as your short ones. And my absolute favorite is people thanking Lex. Like, that's just amazing. People thanking a bot. I don't think I would, but but this we could see this coming through in think about the 3rd day of production. You see somebody saying thank you. I got all my information. That's just wow. So what was our timeline? Fast. 8 2-week sprints, which included Thanksgiving and Christmas. Great time. We had a team of 7. We had our AWS professionals services on board, live in February. We've just continued to grow it. We've got more bots. Our whole architecture is fully scalable, the way we've defined it from the get-go. And this is my last slide, but it's been I've been in the business for a couple of decades. It's absolutely one of the best projects I've ever been on. Just the whole headspace of having to design, having to code differently, serverless architecture, event-driven design. That's where you want to be. I'm going to hand back for a few stats. Dan?
Thank you, Laura. Okay, so jumping back from the infrastructure and design to some of the business metrics, we selected a handful of KPIs that hopefully show the fruits of our labor fairly well, starting with call volume. So you can see it's a fairly linear ramp up followed by some normalization. Each data point there is a week following our MVP. And that was really by design. We purposely throttled call volume to make sure that, firstly, we didn't break anything, that it was an acceptable customer experience, and to really test our ability to learn quickly and incorporate enhancements into the bot. Laura mentioned that for MVP, utterance recognition exceeded 90%, and we've been really happy with subsequent enhancements and functionality. We've continued to keep utterance recognition north of 90%. And that really speaks to our usage of slot values or entities, using real data, automated testing, and gamification there forward. As a result, call deflection has hovered somewhere between 10 to 15% for this rental chatbot. Again, a result we're really happy with. So if you go back to the framework and design of the MVP, we built the chatbot to answer a subset of claims rental-related questions. So while the denominator here might be reflective of everyone that could possibly have a question related to a claims rental car, if you were to kind of normalize that denominator for the functionality we actually built out, you'd see a 2x, 3x increase in this call containment figure, so something we're really happy with. Callbacks, so this is something we've incorporated into our actual call deflection measurement, but something we did want to call out separately. For those that do interact with the chatbot, ostensibly successfully and hang up, we see less than 5% of folks call back within a 24-hour period of time. So tying this all together through the lens of the customer, you heard the survey at the end of the demo. We're receiving average scores of 7 out of 10, with some fun verbatims captured there on the slide as well. And I'll add that one metric not captured on the previous slide, but worth noting, is really the strong partnership and collaboration between traditionally the business side and the IT side, really coming together under an agile framework to deliver what we thought was a really awesome story, and we certainly wanted to share the authors of that story up on this slide. So I'll hand it back over to Mark.
All right. Thanks, Dan.
Yep.
All right, so first I want to say I really like that squad picture, and thanks, Dan and Laura. I was really impressed by how quickly the team was able to start with a basic voice experience, leverage the Voice Foundry UX expert to come in and help optimize that, leverage friends and family and feedback from real customers to really enable more capabilities, increase the complexity, all while learning the services, right? Very impressive in that very short period of time. So let's wrap up with highlighting some best practices that you can get started building with your own self-service customer experiences. So one thing is when you start with, right, pick a use case that really allows you to leverage, prove business value quickly and iterate based on real customer feedback. As you saw with Dan and Laura, providing you some real examples with that, with using Amazon Connect to quickly provision and build and scale the application along with Lex. You can conduct those usability tests with the customers and continually improve the experience with accelerated agility. When customers are calling, right, and focus on building that experience, right? Understand why the customer is calling, leverage the information you have to delight the customer. So, you have all this data, leverage that data. Don't make the customer chase down the information, right, which ultimately is going to lead to a worse customer experience. So leverage that information that you have in your enterprise or in your application, and really try to focus on optimizing that interaction with the customer and answering, why are they calling? Most of the time you probably have a good understanding why they're calling and trying to be proactive in answering that. And then as Laura outlined, it becomes important to really improve building that velocity, as we call it, the flywheel, and really, optimize that voice application, right? Improve the containment metrics, and you'll see there, with leveraging capabilities like CloudFormation, getting out of the console, right? All of those are just some simple best practices that really to drive that velocity and improve that voice experience even more quickly. And as you start to experiment with your voice applications, look for common patterns that can accelerate your implementation. So for example, we have a great blog post on building a Q&A bot. There's actually a presentation session here as well that you can also see that it kind of walks you through how to set that up with Amazon Connect and Lex. So again, you're going to see more and more of these common bot patterns come out around that and common self-service experiences. So leverage those to, in terms of accelerating what you're trying to build for your customer service experience. As I mentioned, customers are often building bots in the console, right? Get that CI/CD pipeline going, right? Get out of the console, start to leverage Lambda, start to how you can, build Lambda behind the scenes, right? To really have an agile, data-driven versioning and deploying approach to optimizing and deploying your voice applications. Look at how to leverage AI with your CRM platforms, right? And Amazon Connect with Lex to capture and quickly escalate the full context of a call, right, to the contact center agents when the complexity of the request really exceeds what you built in the bot experience, right? So you've got all this context of the interaction with the customer. Use that to your advantage. Take that context, pass that into the agent, right? So the agent understands what happened, right? And they can be more proactive in trying to talk to the agent, right? We have, a lot of tools like Transcribe that can, play a role in this and comprehend, right? That can even do sentiment. So the agent can get really a high degree of visibility and understanding, what is the customer struggling with, and the reason why they've escalated into the agent. And when building a voice application, right, Poly you'll see is the common denominator across Lex and Amazon Connect. And really, you want to spend the time, as Laura had talked about earlier with SSML, to really fine tune that, right? SSML really gives you that tagging to add things like inflection and breathing and pronunciation. And finally, start to develop skills that can be leveraged for consumer experiences with Alexa and with your enterprise with services such as Alexa for Business, right? There are thousands of skills. There are lots of open source projects. Start to look at those common patterns, right? Start to pull some of that out in terms of understanding how those are built and using those to build better customer service experience as well. And you really see what's possible there. So with that, thank you everybody for attending, and we've got about 9 minutes to take some Q&A. It's hard to see with the lights, so we'll do the best.
So you talked about limits with Connect on. You talked about limits with Connect.
With Connect and Lex.
Yeah, and what are those actual limits for the?
So we essentially have, if you go into our documentation, you can see for every AWS service we have all the soft limits.
But I mean, like, what are they specifically right now?
Well, an example one is your maximum concurrent.
Yeah, concurrent calls is like 100.
Calls is 100.
100, right? So that's an example of a soft limit that we have, and essentially to raise the soft limit, you would open a support ticket, and then we can raise that limit. Yep. Any other questions?
We can be out in the hallway if folks want to ask
afterwards,
us
if
direct
folks have
questions. We can
one
hang
over.
about out there.
Have a chat.
Oh, there's a question on
No.
the far side.
Yeah, there's one over here.
Can you tell a little more about the role of the 7 members of the team? Like you had a team of 7 on your sprint team. What were their?
So there was a team of 7 developers. We had product owners as well. Like I say, we were mostly Java developers. We were lucky enough to get one AWS expert. He's in the audience, Drew, thank you. Drew is our AWS expert, was able to keep us on the right track, get the account set up, get things like that in place. But yeah, just Java developers, we learned a lot very, very quickly. Again, that's why we started with a Java Lambda and quickly dumped it. But it was a comfort blanket. It got us going fast. That's what you learn fast, change and move on, yeah. Any other questions? Oh, well, the other far side.
She's getting some exercise today.
Okay. Thank you very much. I came from Japan, and we do similar trial POC for customer services. And it's really impressive that you improve from 36% something to 91% in 2 weeks. And is there any other tips to improve the success rate going beyond 75% threshold on top of those modifying coding and other stuffs? Any other perspective that we should try if we are going through the similar journey?
So is this just for the intent testing?
For the utterance recognition.
The utterance, yep.
Yep.
I mean, say that's our utterance refinement procedure is all just about tweaking small words, just for each of your intents. Do you mean, did we do any other testing in other areas? Absolutely. We're a proper team that tests absolutely everything. We did performance testing, and that was full end-to-end, and we used a product called Hammer, Hammer, great name for a performance tool. It's old, but it allowed us to do concurrent calls all the way through. It hit connect all the way through. We could define those tests. And again, that was a fantastic way of us finding out those throttling limits. We talked about the limits, and we hit 2 limits, of which we would not have known without the performance testing. So yeah, it's just like any project. Unit test, do your standalone tests, do your end-to-end. Yeah.
I'll add that with utterance recognition testing, you can almost view it as an optimization model, right? Where you have this output of what is the utterance recognition. You have a concrete set of utterances to feed into that, and then you have however many permutations because you're testing just one at a time. So maybe while I have the platform, be cool to see AWS come out with some sort of tool you could use to really optimize and expedite that process.
Yeah.
Or I guess you could build it in-house.
But I also want to highlight the focusing on that customer experience as well.
Yeah.
Right? Like that's
testing as well.
That's testing as well.
The user experience testing.
Getting real user feedback and
Yeah.
understanding how customers are going to interact with your bot. Right? There's a lot of assumptions that often get made through
Yeah.
that process, and you really want to make time to have that feedback.
Yeah, and so we kicked that in really early on in the project because we were all brand new to it. We didn't want to make mistakes without doing that.
Yeah.
Thank you.
Welcome. Thank you.
Actually, just a comment. I just wanted to say thank you guys very much. That was an extremely clear, crisp, visually appealing presentation that really, it helped wire all these pieces together for me, showing how far you can really go with that.
Thank you very much.
Awesome.
Thank you.
Thank you. Will we end on that note? Fabulous.
Yeah, exactly.
Thank you very much. Thanks, folks.
All right. Thank you.